Hello, hi. Welcome to our community meeting numbers 34 already. So it's hard to believe almost 3 years. So anyway, so let's get started with this week's community meeting. And we have some really interesting items on the agenda. And so we're going to have two demos. Both of them are related to AI and how WasmEdge is being used as a large language model to drive some interesting AI applications. And the other one is upcoming 0.14.1 preview. So for the first talk or for the first demo, a lot of people have known that WasmEdge is great as an inference runtime for large language model. But we have always maintained that WasmEdge should be only device agnostic, operating system agnostic, but also model agnostic, right? So we actually have a large number of models that running on WasmEdge, from computer vision models like ULO, that's was done through a previous LFX mentorship program. And recently we are getting a lot of those, some of those models are more related to large language model and Gen AI into their own application server or their own repository, right? So the ones who stands out are the speech to text models, which because that works directly with large language model as upstream, and text to speech models, the TTS models, which works as a downstream from large language model. So and also of course text to image models and image to text, which is more known as WLM, which we have already supported in the WasmEdge, in the LlamaEdge application server. So, but in this talk, we want to talk about the speech-to-text model, which we actually have two choices. One is Piper, other one is Whisper. Both of them are done by our mentees from the LFX mentorship program. And but for this talk, we want to talk about Piper in particular. So we want to ask Peter Lee to come to give us a demo. However, because he's based in Taiwan, so I think it's midnight there already. So he can't make it live. But he did record a video for us. So what we're going to do is that we're going to play the video here in this talk.
Yeah, I will share my screen to play the video.
All right, thank you.
So
I'm a mentee from the
can you hear the voice?
Yes.
Okay.
mentorship program. Today I'll be talking about the Piper plugin. WasmEdge supports various neural network backends, and this plugin integrates Piper as a new CNN backend. Here's the outline of my presentation. I'll start with an overview of the plugin. Next, I'll show how to install it. Finally, I'll do a quick demo on how to use the plugin in Rust. Let's begin by looking at the plugin's dependencies. The key dependencies are Piper and Onyx runtime. Piper is a fast and local text-to-speech system created by Raspberry. It is written in C++. Piper for Anonymize is a library specifically created for Piper. Some Piper models require speak entry for text-to-phoneme translation. Piper uses Onyx runtime as an inference backend for its Onyx models to convert phoneme IDs to wave audio. The whole process looks like this. The input text is first converted to phonemes. The phonemes are then converted to audio by an Onyx model. Let's move on to the installation process. The Piper plugin requires the Onyx runtime C++ API, so we need to install it first. Installation instructions can be found on the official Onyx runtime website. Here's an example of installing Onyx runtime on Ubuntu. Next, we need to install WasmEdge. Since the WasmEdge installer does not yet include the Piper plugin, we'll manually download the plugin and place it in the plugin directory. Now let's start the demo. The source code can be found in the WasmEdge CNN examples GitHub repo. First, clone the repo. The example we need is in the WasmEdge Piper directory. Next, download the model that will be used in this example. We will need an Onyx model file and a config file. This is the command to download the files. The model we will use is an English single speaker model. This model requires a speak entry to convert text to phonemes, so we have to download the required data for it. After downloading the necessary files, let's take a look at the contents of the example directory. It's a simple cargo binary package. It will be compiled into WebAssembly and executed with WasmEdge. The package depends on WasmEdge WasCNN, which provides high-level WasCNN bindings. The main.rs contains a single main function. Let's see what it does. First, set up the model. We will construct a WasCNN graph with the Piper backend JSON config it passed in, containing the path to the model, config file, and speak entry data. There are additional options to control some Piper parameters, but we will skip those for now. The default settings generally provide good results. You can find more information in the example repo. Next, the input text is set, then the compute function is called to synthesize the audio. Finally, the get output function is called to retrieve the audio bytes, which are then saved into welcome.wav. This is the recap of the process. Then we'll build the example with cargo, and we run it with WasmEdge. Let's try it out. I'm running this inside a Ubuntu container, and I have installed the plugin. Now I'm going to clone the repo. I will clone only the example directory to save some time. Now I'll download the model and data. Now we have these files in the directory, and we'll build it with cargo. Now we run it with WasmEdge. The welcome.wav file has been created successfully. Let's listen to the audio.
Welcome to the world of speech synthesis.
It worked. Maybe we can try it with another sentence. We'll build it again, cargo, and run it again with WasmEdge. Let's listen to the output again.
The quick brown fox jumps over the lazy dog.
Great. I guess that's it. I hope this gave you a good understanding of the Piper plugin. If you're interested in the plugin's implementation, please check out the WasmEdge repo. Thank you.
All right, that's great. Yeah, so, I also realized I made a mistake just now by saying that, Piper is same as Whisper. Obviously it's the other way around. It's similar to TTS. So, so it's text to voice. By the way, we will have chat TTS available and Whisper available as well. So it's so there would be a lot of choices to come to use. And some of you may have noticed that there's underlying library dependencies that we have to install. But that's, in the future, we were, thinking about using the installer to take care of that, like we did with, the GGML plugin at this moment. So, so if you use LlamaEdge, so the key value of LlamaEdge really is to store and manage all those for you, right? So yeah, that's, but the demo you have just seen is pretty much under the hood. So it shows you how those, how those things work, if you have to bootstrap manually, right? And chat TTS would have a different set of requirements. And the other thing I've noticed is that they work with WAV files, so not MP3s and, things like that. And that's, I think that was a good thing because a lot of times you don't really need to see those files. You just stream the audio, so without additional compression and decompression on both ends, sometimes would work better. Your streaming platform would have its own compression mechanism to to make the transport more efficient. So it's often unnecessary to just to encode it in MP3. And if you do need to encode WAV file into MP3, just remember there's a WasmEdge plugin called FFmpeg, right? So it's you can actually in WebAssembly calling those functions and do media transformation. So I have not personally tried that, but I'm sure that FFmpeg on the command line would be able to easily transform WAV file into MP3 and backward, right? So yeah, that's our first demo. I think that's one of our success stories from the LFX mentorship internship program, and I'm sure we'll have much more because the interns who just finished in this semester also had a I think pretty good outcome, and we will have their project to be able to demo their project very soon. So. For the next talk, I'll ask Haidai to talk about the upcoming WasmEdge release 0.14.1. Haidai, please.
Hello, everyone. Can you see my screen now?
Yes.
Okay, great. So today I'm going to show the 14.1 preview, and I believe there are some people already tried the release candidate version. We have the release candidate 1, 2, 3, 4. Currently we are working on the false release candidates due to we are still fixing some minor bug or minor issue on the GitHub action. And after we fixed all of that, we will have the 14.1 release. I believe it will happen in the next week. So today I'm going to talk about the preview of this version. So here you go. And about the highlight of this version, actually we support lots of the new WASI neural network backend, especially the demo you already see in previous section is a demo how to use the Piper to do the text to voice inference, and we have more. And we also update all of the 16 frameworks like GGML, like Llama.cpp, like all extinct backends are already updated to the latest version. And back to the Wasm proposal, we support the Wasm Redux SIMD proposal, so you can have more SIMD related instruction to select your program. And we still continue working on the component model proposal. So we believe we are merge some of the infrastructure, and we're still working on how to create the WASI preview 2 proposal based on this new file structure. And of course, to make all of these features done, we have to do lots of refactoring and the architecture reorganizing to do some new features. So first thing is about our plugin system. We are refactoring the plugin system. So now we already can make some of the external or standalone plugin bundled into the deep WasmEdge. Means that in our previous version, we have the WASI login plugin, which is I believe is a preview. Is a phase 2 proposal, and this proposal is help people to print logs with the very simple signature. And previously we make it a standalone plugin, but we found that there are lots of people they would like to use this feature, but to use it as a standalone plugin will cause some trouble because they have to install this plugin on different platforms. To reduce this workload, we just bundle it into our WasmEdge, and we are going to provide this mechanism to offer the people in the future release. So in the future, you can have your own plugin bundled with the WasmEdge. Yeah, but now we're just refactoring all of data structure, all of logic to make this behavior done. Also, we do lots of the refactoring to our CI workflow. The reason is because that we are now support a new distro, which is the Mentorship 28, and this version actually is based on the Linux 8. The GDVC version is use the 2.28. The reason is that the CentOS 7 is already, and we would like to deprecate it, so we have to find out a new CentOS related distro and to build our asset to make sure that all of our users which are use the CentOS 8 or Linux 8 can have the correct assay to execute the whole workload, including all of our AI or LLM workload. Yeah, so to introduce this one, we have to reflect lots of our CI workflow, so you can find lots of pull requests all related to this. And of course, if you are very familiar with the multiple distro or multiple way architecture, and you would like to help us with the workflow, we are very welcome. Yeah, so here is some highlights in this version, and let's go deep into during these months we are working very hard to introduce more and more WASI neural network backend, including we are bump the Llama.cpp to a very latest version, and we also integrate the Intel Neural Speed framework. So if you are familiar with the Intel framework like the One API or something like that, you can use the Intel Neural Speed framework to execute your LLM framework, or your LLMs or any AI models which can support by this framework. And we already support some, the voice to text. Use the Whisper.cpp, so you can give audio. You can give audio to our plugin, and you will try to transcript your audio to a script. And also we support some of the features layer, so you can specify the prompt. You can just throw it and decide what kind of output you really want. And we also support two of the text to voice framework. One is the paper, and you already demoed in the previous section. And we have another one is ChatTTS. So if you are interested to use any one of them, you can just try it. And we also introduced a new, the Rust programming language based framework called Burn. And currently we have two demo. One is the SqueezeNet, one is the Whisper. And we are working on the Burn LLM. So in our future version, you may, run the Llama 3.1 with the Burn framework. Yeah, so we support lots of new backends, so you can use the existing WASI neural network interface to interact with them. Also, we support the stable diffusion.cpp, so including the stable diffusion model, including the flux model, you can use them. And I believe we already support the text to image and the image to image features in this plugin. So if you are interested, after our 14.1 released, you can try it. And we also support the LLM.z if you are interested in using WebAssembly to do the model training. And yes, we have a very very initial support of it. So you can just have a very you can just train in your GPT model on scratch. So if you're interested, you can try this one. Yeah. And what's new? Well, we have in our 15.0 release. And yeah, we are focusing on the following things. One is that we want to introduce the WASI virtual file system support for all plugins. So it will help you to open a file, control all your files with the WASI virtual file systems instead of the host file system. Yeah. The second one is that we already introduced the WASI login, which is already bundled in the WasmEdge library. And due to some use cases, our users told us that they don't want to do any dynamically load in their workflow. So they would like to choose some of the plugins bundled with the WasmEdge library. So we will provide this feature in our next module release. And also we are ready for support more component model features. So we are having more WASI Preview 2 support in our next module release. And the remaining thing is that this is a notification is we are going to deprecate the Maninears 2040. This one is based on the CentOS 7 and already end of life. So we would like to remove all of the support since the 40.0. So the previous one, this is a highlight of our next week release, and these are the the future works. So that's all I have. Yeah. So let me turn back to Michael.
All right, Hadai. So lots of features for point release. So yeah, we have it took us a long time for to getting the release process ready, but I think we're finally there. So so we should be able to make releases at a more stable cadence from this point now. And also, as I said, we have because we have now a lot more builds and a lot more platforms and models and devices that we target. So we are looking for help either through internship or through other programs. That's to help us streamline the CI/CD pipeline, right? And the good news really is that CI/CD, you don't really need your own machine or a powerful machine like a lot of our AI work. You really need a GPU machine on your end in order to to work on those. The CI/CD is all on the server, right? So or mostly on the server. So that's so if someone's interested in helping out that, we would really appreciate that and work out some way to work together. Anyway, so yeah, so let's move on to our last topic. I'd ask because one of the most popular thing that's happened, blow up on internet, as they say, is Cursor. Right? So Cursor recently raised $60 million, and people were surprised because they thought it was just a ChatGPT wrapper, and immediately after that, I think Magic and Codium also really raised over $100 million each, right? So that means there has been a breakthrough advance in what we call AI coder. This is actually a very interesting advancement to me, because I have thought this field has been dominated by GitHub Copilot. GitHub has the technology, has the latest models, in fact, early access to other models that other people don't have access to, and has the captive audience because we are all on GitHub. So GitHub Copilot would definitely be the one to win, right? But is it? No. That's so the field is wide open now. That's you see all those new product with new product features, and they have a real chance of beating GitHub Copilot. That is something that I would have not thought only a month ago. That's I would not thought anyone has any chance against in this area against GitHub Copilot. But that also means the field is open to us, right? So we have worked on WasmEdge integration with Cursor for some time, so I'd ask Vivian to come to make a demonstration for us, and I'm hoping this would be useful in your daily work as well. So Vivian, please.
Thank you, Michael. Let me share my screen. So I'm going to demo how to use Cursor and the local LLM to build a RAS application from zero. So if you have downloaded Cursor on your MacBook, you can see that it supports GPT and the cloud. It's all closed source large language models. But in here, we have a override OpenAI based URL. That means we can customize. We can customize the models that we are using. We can use the local LLM. We can use self-host LLM. So why we need to use a local host LLM, because we can make some customization about the large language model. We can add some knowledge to the model, and other advantage is that we can keep privacy. All the data will stored in our own machine instead of going back to OpenAI's machine. So to use local LLM in Cursor, we will need to have HTTPS link. However, as we all know, WasmEdge can only create HTTP link for us. So I will use Gaia as a user. So let me go back to my terminal. Before I start, I want to show you how I customize the Llama 8 billion model. Here you can see that I snapshot. It's the content source is from RAS by example. So from using this snapshot, I can make the Llama 3.1 billion model with RAS knowledge. Next, let's start running this RAG application. Oh, sorry. So at first, we'll start a QRun instance because our knowledge embeddings is stored in the QRun's vector database, and then it will start the Llama API server. So we use this command line to run the chat model, Llama 3.1 billion model, and also an embedding model. The embedding model I use is nomic embed text. Finally, we will get an HTTPS link. We can share this link with others, so everyone can access the RAG application I just built. Let's open this. Let's open this link first. Because I'm not familiar with RAS, I'm not a programmer. So I'm going to ask my first question: how to create a project from scratch. But I don't know why this is so slow. Okay. So I'm going to ask the large language model a basic question: how to create a RAS project. We can also go back to the terminal to see the log. Because this large language model, this RAG application is running on my MacBook. As you can see, my MacBook only has 16 gigabytes memory, so it will be slow. Okay, I think we will have some response. Okay, so the first step is to install Rust. I have done, and then I can use cargo new my project to create a new directory with the basic structure for Rust project. So I will do it first. Let me. So I can go to Cursor because it's already an IDE. Okay, this command line works. Now we have a cargo new folder, and then I will use Cursor to open the folder. The community meeting is the project I just created. Okay, next let's configure the Cursor. So I mentioned before, we can use override OpenAI base URL to customize the local LLM. So I think the link is this one, and click on save, and then verify. Okay, so the verification is successful. Then we can go back to the editor. We can use Command and K to edit the code. So let's change the code to be to a simple to-do app, and then we can submit edit. Again, because the large language model is running on my MacBook, on my personal computer, it will be slow. Let me try again. Okay, let me check out the link works.
I think maybe you are running too much stuff. It killed the WasmEdge process.
Okay, let me
You should PS to see if the WasmEdge process is running on your node.
okay, so WasmEdge process is running.
Okay.
Okay, let me try. I'm sorry, it fails again.
Maybe you should try the web UI again. Just to, that's where live debugging here. Just to write this command in the web UI, write a to-do app.
Okay, I will go back to the web UI. So I think there is something wrong because the large language model didn't respond to me.
You can always restart your Gaia node. I think there's the machine has too much stuff. You're live streaming, you're running Cursor, you're running a vector database, you're running everything on your machine. So, does the log show anything, or the log just stuck there?
Log didn't show any errors. So yeah, I can restart okay, then I can go back to the Cursor to try again. Okay, it helped me rewrite my Rust code, but it's too simple. I think I still have a couple minutes, so I will ask a follow-up question. Support sliding and deleting and archive, and then ask the large language model to rewrite it again.
Are we still waiting?
Yes, because we just met another connection failed, so I submit again.
Yeah, it's unlikely to work because it's a connection failed for a reason. I think that's the same problem you had before. Yeah, it wouldn't work just by retrying. I don't think. Perhaps you can just show the video. Go ahead.
Maybe it's a network error. I didn't open my VPN.
If this fails, I think you can just I think you can prepare to show the video that you had. That's because that goes through the whole process instead of debugging it here. Because I think, if it failed, if you don't know why it failed, it's unlikely it's gonna work.
Okay, I will show the demo that I recorded before, and I'm sorry.
I'll show you.
Yes, the demo is made by me, but Michael helped me record the voice.
In this demo, I'll show you how a large language model running privately on my laptop helped me build a complete Rust application from zero without any prior knowledge of Rust. The large language model is based on Llama 3.1. It is fine-tuned and supplemented with knowledge about the Rust programming language. I'm running everything on my laptop using the Gaia network software. I first asked the AI how to create a Rust project. It says cargo new. So I go to the command terminal and create a new application for to-do list. In Cursor, I now open the project folder I just created. It shows me the initial project files in the folder. The large language model we use to write code runs in a GaiaNet node on my computer. I'm running the large language model with a knowledge base derived from Rust by example book. While the node runs on my laptop, it actually has a HTTPS public URL for other applications to connect to. Now go back to the Cursor and open settings. I can now add a new AI backend using the URL and the model name I just started on the local Gaia node. Now I tell Cursor to edit the Rust source code in the project template. I wanted to create a to-do list app. Well, it just writes code to print out a list of to-do actions. That's not very useful. So I follow up and ask it to support adding and deleting to-do items in the app. Now it generates code that stores and manages the to-do items in a Rust vector. That looks good, so I accept it. But I do not know how to build and run this app. So I'm asking the AI about it. It tells me to use the cargo build and the cargo run commands. So I run cargo build. But through the compiler error, I go back to the chat and ask the AI to look into this error. The AI already saw this error message and tells me how to fix it. It now compiles and runs. But the to-do app starts and immediately quits after I hit return. So I'm asking the AI about how the code works. It explains the commands I need to use to work with the to-do items in the app. Great. Let me try again. Cool. I have a to-do app written in Rust now.
Yeah, that's demo I want to show you today, but somehow it doesn't work on my computer. But the original demo works on my computer. I don't know why, and I'm sorry for the experience.
Okay, no worries. That's so yeah, that's so I guess that's conclude our this monthly meeting. So yeah, so for everyone who's watching on the internet, that's if you have further questions, please do get in touch with us through GitHub or through other means. All right. Okay, so I think that's it for today. Thank you so much.
Bye.
Bye-bye.